All right, good afternoon. You're welcome to our today's class. We are still on the course physics. In our last class, we treated what is it called? We stopped at collinear motion. We stopped at what? Collinear motion, right? We are here in the class. Okay, two of you not there. Is after this class, try to get notes from them, okay? And we discussed before we enter that collinear motion. We discussed types of motion and what relative what motion. And we wanted to solve some questions in types of motion and relative motion, but because there was no past question, so we could not do that. Did it come with past question? Good, let me see. Is it arranged by topics? Did it come with past question? Look for the one that is arranged per topic. It will be easier to find questions. Please. But let me see if I can get question. I'll leave question from types of motion, then question from relative motion. Let's take it off from there, okay? So I prefer those ones that have questions arranged according to the topic, so that you just go straight to the topic and pick the question. But this one now you start selecting from start going through all the questions before you can pick out the question. Please try and be coming with your past question. At least we will be bringing out no less than 10 minutes to every day to look at past question. Okay? All right. Okay, when we introduce motion, when we introduce motion, I mentioned key factors that you must look at before we do what? In motion, right? And displacement is one of them. True or false? So, and the displacement talks about position. I told you, position, right? That's the key word. Position is the key word. Am I communicating? So because of that now, even though we did not go deep into it, I want us to solve questions. I can see two questions here in 2024 JAM physics. Let's solve questions in that displacement and take it off from there. Is that clear? Or I put down the question. That is 2024 JAM question. 2024 JAM. That's question 2024 JAM question 12. Question 12. Oh yeah, put it down. This question is on the displacement, okay? A man moves 20 meter north. A man moves 20 meter north, comma, then 12 meter east, then 12 meters east, and finally 15 meter south, and finally 15 meter south, full stop. His displacement from the starting point, his displacement from the starting point is now A 13 meter, B 27 meter, C 47 meter, D 23 meters. 23 meter. 23 meter. Are we there? Are we there? All right. Put down the second question. The second question is Descent Jam 2024, question 18. Question 18. It says, a man walks 1 kilometer due east. A man walks 1 kilometer due east, and 1 kilometer due north, and 1 kilometer due north. Full stop. His displacement is A root 2 kilometer, root 2 square it, root 2 kilometer north 45 degree east. No, see how to write it here. Root 2 kilometer north 45 degrees east. Is that clear? That's option A. Option B, 1 kilometer north 30 degrees east. 1 kilometer north 30 degrees east. Option C, 1 kilometer north 15 degrees east. Option C, 1 kilometer, option C, 1 kilometer north 15 degrees east. Are we good?
Yes, sir.
Option D, root 2 kilometer north 60 degrees east. Root 2 kilometer north 60 degrees east. Is that clear?
Yes, sir.
So let's solve these two questions and see how far we can go with them. All right. Call the first question. Solution. Just one person should call it. Why? Because as you are calling, I am sketching.
A man moves 20 meters north.
Okay, wait. Have you heard of cardinal points? Cardinal points. Cardinal point is like this. Where you have north, south, east and what? Is that clear? That cardinal point. Okay, you now know it, right? Good. You know about Pythagoras theorem? I will now see why I keep telling people, even if you're not doing maths in JAMB, when maths lecture is going on, don't go. Stay there and listen. There are some things you will need to. Maths and physics, they have a lot of things together. Is that clear? Now, we are going to apply some mathematical principles here to solve this question. Now, since you know this cardinal point, so before, if you're determining position of an object, you must use your cardinal points. That's why if you see that in the use, what is it called? That in they used to know the direction, compass. It has cardinal points. Tell you whether you are north, whether you are south, whether you are east, whether you are west, whether you are northeast, whether you are southeast, whether you are southwest, whether you are northwest. It will show you. Is that clear?
Yes.
Now, let us now solve the question. Or as you read, I will sketch. Or read.
A man moves 20 meters north.
So the man, let's assume the man started from a point. Are you following? The man started from a particular point. Let's assume, and at that point, the man started from, you draw a cardinal point there to determine that position. The man started, let me go at the center. The man started here. Is that clear? Is that clear? And here is what? North. Here is what? South. Here is what? And here is what? So this is where the man started. Continue.
The man moves 20 meters north.
North. So this is north, right? The man started from here and moved 20 meter. 20. Take this at 20 meter. Is that clear? There should be another cardinal point here. Is that clear? This is north. And here is still what? North. Here is still what? Here is still what? Here is still what? For this position, here is south. Here is east. New position. Here is east. Here is north. Here is west. He left from here and moved north. I follow you. Continue.
Then 12 meters east.
Here is 20 meter, right?
Yes, sir.
This is east. They said he moved what? 12 meter east. He moved only 12 meters. That means 12 meters should be shorter than what?
20 meters.
Small thing, half of this, right? So that means the man moves something like this and stop. Is that clear?
Yes, sir.
You put another cardinal point here. Is that clear?
Yes, sir.
Here is what? 12 meter. For this new position, here is west. Hope you know.
Yes, sir.
Here is north. Here is what? East. And here is what?
South.
South. Continue.
And finally 15 meters south.
Finally what?
15 meters south.
15 meters south.
Yes.
The man now move 15 meter. Look up. 15 meters, this is 20 meter. It should be less than this and more than this. So we move 15 meter, maybe somewhere here. You put another cardinal point. No. Maybe somewhere here. Is that clear? You put another cardinal point. For this position, here is still what? Here is what? Here is what? Continue.
His displacement from the starting point is now
What? Good. Remember, in our last class, I told us when we were discussing those factors, I said that if a body starts a journey, if somebody, an object or somebody starts a journey and move and go to another position, if you want to check the person's distance, you calculate all the length of the path taken by the person. That will give you the what? Distance. But if you want to calculate displacement, it's not all the paths. It's the shortest route that you take, that you do your calculation. Because the displacement is focused on the person's position with respect to the initial position. And the angle, the direction, because displacement is a vector quantity. So the distance and the direction, depending on how the question comes. Now, let's assume we want to calculate the distance. All you need to do is just start calculating 20 plus 12 plus 15. The man's distance is what? Distance travel is what? 20 plus 12 is what? 32 plus 15 is what? So the distance covered by that man is what? But it's not the same thing with what? The man's displacement. So if you want to check the man's displacement, you check the shortest route. The man's displacement is just from here to here. If you calculate this length, I follow you. This length will give us the man's what? Displacement. It's not the man's distance. If the man's distance is all these things he has been traveling at this point, I follow you. I'm trying to put that thing I explained to you in the last class in calculation. Am I making sense? Now, this is the man's what? Displacement. Because now, by right, displacement has two components because it's a vector quantity. It has magnitude and direction. The magnitude is the length. Length is from here to here. But direction is from the initial point. This angle will give you the what? The direction. Between the man's position is now north east of the original position at a particular angle. Am I communicating?
Yes, sir.
But we are asked to find the what? The options. Is it in meters? Is there any angle in the options? So let's find it. Let's find the magnitude part first before we now. But the standard displacement, you have the magnitude part and the what? The angular part or bearing part. That's why you do your bearing and distances in your mathematics. Bearing and distances is nothing but what? Displacement. That term, bearing and distances, is nothing but what? Displacement. The distance is the magnitude part, while the bearing is the angle part. Am I communicating? Let us not go there. Let us just calculate. Let me claim this theta first. Let's calculate this displacement. So how do we calculate it? How do we now do this calculation? It's simple. Who can tell me what we can do here? It's very simple. Any idea? Who can tell me? No idea. No idea. Now look up. This looks so rough, right? Let me bring it out as a plane shape somewhere here. If you bring this in now, what type of shape is this? Trapezium, right? Let me bring out this shape. If you bring it out, it looks like this. Three of us. This is where the man started from. And move here, and move here. But here to here is what? 15 meters, right? Here to here is what? Here to here is what? We can extrapolate from here, have a straight line from here. We can have a straight line from here. Because this thing can cut this way off to form a right angle what? Triangle. True or false? Now look up. If here to here is 20 and here to here is 15, here should be what? 5, right? Are you following? Here is what? Are you with us? So here, if here becomes 5, let's write this 20 here. If it becomes 5, that means here is what? Here is what? 15, right?
Yes, sir.
Here is what? 5. We are good to go. We are found here to 5 meters. We are found here. We don't know here. This is the S we are looking for, right? This is a square, right?
Yes, sir.
If here and here is the same thing, here should be what? The same thing. I follow you. So here is what? 12. We have formed a right angle triangle that has 3 sides. And this side is opposite this side. If you look at it now, if you look at it like this, look at it like, tell me where is the opposite and where is the hypotenuse. Don't mind my shape. Look at how the angle lies. Which one is opposite?
Opposite. No, opposite is 12.
Okay, let me draw a normal right angle triangle. If you like, you can bring this out to. In fact, let me bring this out as a right angle triangle and then draw it well. This is right angle triangle, right? Right?
Yes, sir.
This is the angle, right?
Yes.
And if you do this in well, here is what? 5 meters, right? Here is what? 12 meters. Here is what? What I'm looking for. So, which one is the opposite?
5.
Good! Here is opposite, right? And here is what? And here is what? So, which rule are we going to use now? Pythagoras theorem states that in a right angle triangle, the longest side, which is the square of what? Square of what? Huh?
Square of the hypotenuse.
Is equal to what?
Square of opposite plus square of adjacent.
Square of what?
Opposite
Plus what?
square of adjacent.
Is that clear? Who doesn't know this rule? You know it, right? This is Pythagoras theory. So let's and the hypotenuse here is what? The S we are looking for. So let's do it. So that means S, which is the displacement, is equal to what?
5 square.
5 square plus what? 12 square, which is what?
25 plus.
Sorry, S square, sorry. Are you following? Which is 25 plus what? Which is what? 169. Remember everything is in meter, right? So that means S square is 169. That means S is equal to what? Square root of what? Which is what? 13 meter. Is that clear?
Yes, sir.
So the displacement is 13 meter. Please, this is just the what? This is just the magnitude of the what? Displacement. So how did they ask the question? We should find what?
This displacement from the starting point.
Anyway, let me just take it. But by right, the right thing would have been the magnitude of the what? Displacement. They should have put the magnitude there. Because if you say displacement, the displacement is a vector quantity, you should have the magnitude side and the direction side. So the option should include the direction side. But since the option has no angle, it's just the magnitude side. So the question should have been the magnitude of the what? Of the what? Displacement. That's when the answer is 13 meter. Which option is 13 meter? Which option is 13 meter? Second, A is the answer. A is the answer. But I'm trying to tell you that by right, the question should have been framed like this. What is the magnitude of the what? Displacement. We know that it's looking for the magnitude only, not the what? Direction. Is that clear?
Yes, sir.
But now I want to open your eyes to tell you how to find that direction. Is that clear?
Yes, sir.
Because the next question we include direction. That's why I want to use this one to show you now. Now, remember the journey started from here. Bearing. Imam, this is the direction. This theta here is very important. Let's find that theta. Because the man current direction is not east or from the initial what? Position. Starting from the initial position, the man is not east of that initial position. So you should find the angle which is, so the angle should be, whatever you find there, it should be not that angle east. Is that clear? Not that angle east, because it's between north and east. So let's find this angle. So the direction is not theta. Direction is not theta what? Theta degree what? East. That's the what? The man's direction. But the man's magnitude of the displacement is what? 13 meter. So actually, if you want to write the displacement in a normal way, it should be, the man's displacement should be what? 13 what? Meter, not what? Theta is degree east. That should be the correct displacement. Because it has two components. This component is what? Magnitude. And the component is what? Direction, as a vector quantity. Does it make sense?
Yes, sir.
Are you following? Are you sure? Now let us now find this theta. So where do you think, if you are to look at this thing we have carved out, where do you think this theta should be? Check well. It should be here, right? So where do you think it should be here?
No.
Up here, right? So this is the theta we are looking for. Because we have turned like this, right? So this is the angle we are looking for. Are you following? Please don't say you're following when you are not following. This is calculation. And once you know it, you have learned it. No matter how they twist question, you can answer it. Jam didn't ask this one. I'm the one that's solving it because I am correcting the mistake they made there. That question is not well framed. It's if they want it only to be that emit alone, it should have been what? It should have been what? Find the magnitude of the word displacement. Then, but if they just say displacement, it means it should contain both words. So I'm trying to find this one now so I can put the answer the way it should be. Now so this theta is what they are fighting for. Remember so ka toa. Remember so ka toa. Remember. Now we have agreed. This is sine, right? Sine meaning what? Sine theta is the what? Opposite over what? That's this one, right? Cos theta is what? Adjacent over what? That is one, right? Tan theta is what? Over what? That is this one. So it's clear. Now, look at this thing now. Our target is to find theta. We have succeeded in finding the here. What did you get here?
13.
These are what? These are what?
Adjacent.
Ta-down.
Opposite.
Ta-down.
Now adjacent because of theta is facing.
What we are finding is theta, not here. For this theta, for this, are you following? Because of this, remember initially, our target was just based on here. The theta was here, right? But now, the theta is now here. So, which one is the opposite?
Sorry.
This theta, opposite to this angle is what? Huh? So this 5 is opposite to this. The first thing we did, we are not finding this angle. We are just trying to find this side. With that one we did before, we placed theta here. Our angle, we anyone we placed here. That's when this was the opposite facing. But now we are looking for direction, the actual direction. This is where theta is. Remember, we turn it upside down. So the theta is now what? Here, the theta is here. So which one is opposite? Good. Here is what? Opposite. Adjacent income? 5, right?
Yes.
It's adjacent. Are you following? Hypotenuse income?
13.
So our target is to find what? Theta. If since all the sides are complete, anyone we choose will give all this. If we say cos sine theta is 12 over 5, will give us what? Sine.
12 over 13.
Sorry, 12 over what? 13 will give us sine theta.
Yeah.
So sine theta is what? 12 over what? 13. Tan theta is what? Tan theta is what? Tan is opposite to opposite over what?
12
said 12 over what? 5. Then cos theta is what?
5 over 13.
5 over what?
13.
All this will give us the same thing. If we find theta, remember, if all these things are theta, so if all these things, hey, there's no space again to write. Put down so I can continue. Put down, please. Put down so I can clean the board and continue. I want to solve all of them at the same time, so I have to show you that they give you the same what? Result. Is that clear?
Yes, sir.
All right. So from what we did here, if we have sine theta is equal to 12 over 13, that implies that theta is equal to what? Sine inverse, right? Remember, sine inverse. Are you following it? Sine what? Are you with us? You know about this one, right? Huh? Sine inverse of what? 12 over what? 13. True or false? So 12 over 13 is what? You can leave it at 4 decimal places. It's okay.
0.923.
So sine inverse of what? 0. What?
931.
923. So what's the answer? So theta is now. What's the answer? Do sine inverse of
67.38.
67 point what?
38.
Let me do 67.4. Is that clear? Is that clear?
Yes, sir.
That's this. Are you following? Are you following? You are following. Now we can solve. Let's try tan theta and see what we will get. You can choose any of them. I'm trying to do all of them to show whether we'll get the same answer. Is that clear? So tan theta, if you choose tan theta, if tan theta is 12 over what? 5. That implies that theta is equal to tan inverse of what? 12 over what? 5. Which is equal to what? Tan inverse of what? 2.4 dot, right?
Yes.
So, which is what? 67 point what? So 67.4 degree. Now, then cos what? Theta is what? 5 over what? 13. Please, if you are lost, let me know. Please call my attention. So if you choose any of the one you choose, will give you the same answer. So if you choose cos theta, you have 5 over what? 13. That implies that theta is equal to cos inverse of what? 5 over what? 13, which is equal to cos inverse of what? 0.3846. I find the, so theta is now equal to what? 67.4. So anyone use will give you the same answer, 67.4. Is that clear?
Yes, sir.
Are you done with this side? Are you done with this side? So just look up. Let me now write how the displacement should be. That is standard way of writing displacement. So the displacement should be displacement of the man is equal to, if you first write the magnitude side, remember that it lies between north and north and east in that thing I wrote. Now this, look up after I continue. So displacement should now be, you write the magnitude part, which is what? 13 meter. Not 60 what? East. This is how the displacement should look like. This is how the displacement should look like. But in the question, they only focus on what? 13 meter. If you look at the second question, they got it right in the second question. They asked us to find the displacement too. They included in the option, they included the what? They included the what? Magnitude and what? Direction. Is that clear? So I want you now, try that one at home. Okay, I will stop here because I have other class I need to catch up with. So I will stop here for today. Maths took our physics time, but no problem. Just try to solve that one at home and solve other questions that has to do with this topic. Is that clear?
Yes, sir.
Is that clear? Any questions so far? Any question? Any question? No question. All right, thank you very much for your attention. See you next time.